Alright boys, this is what we're going to work on in Friday's lesson. I've got some Google Slides here. I'm just going to try and talk through them, and hopefully this will make today's work nice and clear. So what we're doing today is factorizing quadratics. And so what does that mean? So you might remember before the Easter holidays, we were working on expanding two sets of brackets. And what this is the exact reverse process of that. So going from the answer from when you expand two brackets back to two brackets. Okay, so we're going to have a look through what this means. Okay, so what are the learning outcomes today? So the learning outcomes are quite simply to be confident to factorize a quadratic into two brackets. And what is a quadratic? A quadratic is the equation of a curve. Okay, so what are we doing? So we are reversing the process of expanding two brackets. Okay, look at these notes and see if you can follow. So I'll upload these slides as well. So what we did before Easter was we would have something like this, x plus 4 in brackets and x plus 3, and we've expanded this. And you might remember the order you go through this is you first multiply, you might remember it's called FOIL, or you might have heard that term before. FOIL standing for F for first, O for outers, I for inners, and L for last. So first you multiply x by x, which gets you x squared. Second, you multiply x by 3, the outer terms, to get 3x. Then you multiply the two inner terms, 4 by x, to get 4x. And then you multiply 4 by 3, which gives you 12. You write all of this out in one line, x squared plus 3x plus 4x plus 12, and that gives you x squared plus 7x plus 12. What we're doing today is reversing that process. We're going from x squared plus 7x plus 12 back to brackets x plus 4 upon brackets x plus 3. So what we need to learn to do is how do we go about this process? What I've asked here is can you identify any patterns? Okay, and what I mean by that is can you spot how x plus 4 brackets x plus 3 can become x squared plus 7x plus 12, or how can you identify from this how you could maybe get back to this initial point? How can you get from x squared plus 7x plus 12 back to x plus 4 and x plus 3? So what I've asked here is what patterns do you notice? Do you spot that obviously 3 and 4 multiplied give you 12, and 3 and 4 added give you 7? Okay, so another example of x squared plus 9x plus 18. If we're looking for numbers that can multiply to get us 18, but also combine by addition to get 9. So possible factors of 18 are 1 and 18, 2 and 9, 3 and 6. Do any of these combine to give 9? Yes, 3 and 6 do. Okay, so we know then that in our brackets we're going to have x plus 3 and x plus 6. And if you multiply that out to check, x squared, 6x, 3x, and 18, 6 and 3 gives us 9. So that gives us back our initial question. So that's going to be our answer, x plus 3 and x plus 6. Okay, so what I've got here is 3 examples for you to work through. I've got an example on the left hand side and a your turn question on the right hand side. Okay, I've got 3 of these on these 3 slides. So the first one, the second one, what's different here you'll spot is we had a negative 14. So you're going to have a think about how that can work. Okay, so the brackets aren't always going to both be plus. If they're both plus, it's nice and easy, but it's not always going to be the case. Okay, in this case we're trying to get factors of 14 that can combine to get us to 5. So a positive 7 and a negative 2 will get us 5. 7 minus 2 is 5. 7 times negative 2 is negative 14. So you can have a look through that one. And example 3, now we've got a negative x term and a positive final term. So this time it's a little bit trickier. The correct combination of factors is going to be negative 4 times negative 3, because multiplying two negatives gives you a positive 12, and subtracting two negatives will get you negative 7x. So that's another one you can look through. Okay. I have a further YouTube demonstration here you can have a look through. And the final question, why are we doing this? What's the point? So what we can see here is if you draw the curve, you might be able to spot the connection between the original quadratic and where it cuts the x-axis. Okay.